Hello. So in today's video, I'm going to show you a bit of fun stuff to add to your drone. This is purely for fun. There is absolutely no functional purpose that I can think of yet, but I've been wanting it, and so I'm going to add it. What it is a NeoPixel LED light strip. Each of these LEDs, you can change the color, you can change the brightness, and you can control which ones are actually lit up through programming. So what I plan to do is wrap it around the front of my drone, kind of on the top that I crafted, the big plastic top that I 3D printed in a previous video. Attach it to that, and then connect it to the Raspberry Pi, and use Python to program a little bit of a Knight Rider or Cylon scanning pattern with an LED going back and forth. I don't know, just a little bit of fun, make it look like something out of Skynet, who knows. So yeah, I'll show you how to hook this thing up and how to connect the wires and do some of the programming on it. So let's get started. All right, if you've been following my build series here, you've already printed this lid to mount the LiDAR that was in the last video. However, if you didn't, in the wiki page for this video, I got a download link to the STL file so you can 3D print this lid. Okay, this is what it looks like with the LiDAR mounted, if you followed the instructions in the last video. But what's important is I added on two more pieces. One is this LED channel holder that's designed to fit over the lid, and it's got some holes in there to run the cables through and everything. And then it's also got a translucent piece that's going to cover the LEDs and keep all that secured and give it a little bit of a cover to protect them. So to start off, you need to have those 3D printed to be able to build this. So you need three pieces, and there's 3 STL files linked in the wiki page. You're also going to need your NeoPixel lights. So this is the one that I bought off of Amazon, and it's got 144 LEDs per meter, and this is the packaging that it came in. CIZO, I guess, is the manufacturer. And there's the back of it, looks like. Okay. And it's going to come on a roll like this, and we're going to end up having to cut it to length to fit on our thing. And there's, on the one end, it comes with this connector with the white, green, and red. And then it also comes with these two additional white and red cables that we're not going to need. Okay. What else you're going to need? You're going to need a 330 ohm resistor. I bought some resistors on Amazon in a little pack, but we just need a little one that we're going to put in line with the data cable from the LED strip to the Raspberry Pi. You might want some split sleeving to cover these wires that go inside the lid. Got some zip ties, got some wire cutters, scissors, and then I got some CA glue to glue this stuff together. And lastly, we got a cable that we're going to make. So let me talk you through how I made this cable first of all. Now, the LED lights came with this end here, okay? It came with that inside the box, and it connects right to the other end that's already attached to the LEDs. And what I did was I took one of these connectors. I can't remember what they're called. I think it's a GH connector. I have a link in the bill of materials for this whole build, and this is what I used on that octopus cable coming off of my BEC, so that I have plenty of 5-volt ports in my drone to power other auxiliary devices like this. Okay, and so what I did was the green cable, let's start there, that's the simplest one. There's a 330 ohm resistor in the middle here that I soldered. I already built this, so can't really show you what it looks like, but there's a 330 ohm resistor there. This wire connects to one end of the resistor, and then this other green wire connected to the other end of the resistor. And I put some shrink tubing over it. This is a DuPont connector on this end, which will let me plug it right into the top of the Raspberry Pi header. Okay. Next wire is the white wire coming off the connector. That's our ground. And we need 2 wires connected there. I have one and these are all just joined together here, but one is going just to a DuPont connector because I need to attach this to the ground as well on the Raspberry Pi to give it a stable data transmission line. And then the other end, or the other wire going to it as well, is again this GH connector, I think it's called, and connected to the black wire there. So that's going to plug into my BEC circuit. So all three of these, this white and then the two black wires, I just twisted them together, soldered it, put some heat shrink tubing over it. Okay, so those all just connect together like that. And then the last wire from our connector that's going to go to our BEC to power these is just the red positive wire, and that connects to the red wire here and some heat shrink tubing. Okay, so that's the cable you're going to have to make. And if you use different connectors in your drone, feel free to adjust this, but there's three important wires in here: positive, negative, and then the data wire. Okay, so what we want to do after you have your cable built and after you've 3D printed everything is we're going to take this lid, and we've got our two pieces here, the LED channel and then the translucent cover, and I'm going to go ahead and twist it so that the front is pointing away from me. Okay, and in the LED channel I printed it where one side has these two, I don't know, they're almost half-inch holes, maybe a little bit bigger, that are used to be able to run the wires through. So this thing is only about 1 millimeter bigger than the actual top of the lid, and so it slides on pretty tight. In fact, you really don't even have to glue it if you don't want, probably, but I'm going to go ahead and glue mine. I might glue it off this video though, because I think I want to maybe make some adjustments going forward. So it just slides on, and you're going to slide it right to the top of where this chamfer, this 45-degree angle ends. Okay, so slide it to there, and it'll be sitting on there kind of nice and tight. Now in the lid, in fact, I'm going to go down a little bit more. Going to spin it around a little bit, try to get this thing even on all sides. Okay. Now in the lid itself, I did not include these holes for that I built into the LED channel. So what I think you're going to want to do, in fact, I put this one on upside down from the way I drilled the hole. What you're going to want to do is drill a hole through into the lid. If you grab the Autodesk Fusion file, you could probably just modify it and include the hole right there if you wanted to. Because I thought of this after I already built this lid, I don't have a hole already designed into the lid. See if that lines up a little better. Yeah. So the reason I flipped it over, it doesn't matter until you drill a hole, is I grabbed a 1/2-inch bit and I just drilled a hole straight through, so I got something going into the lid of this drone. Okay. So that's looking pretty good. All right, so that's what that looks like. And you got a hole going in. I did put some of these smaller holes right in the middle on all 4 sides as well, in case you wanted to instead drill a hole through and screw it. But be aware that the screw will be under the LED strip, so you might have to insulate it a little bit. All right. Now, what we can do here, I think I am going to glue this top, but I'm just not going to glue the translucent cover on. You can take your CA glue, and hopefully this works. Yeah. Sometimes it gets gunked up in here, and you got to take a pin and shove it through. So I'm going to take the CA glue, and I'm just going to put a couple light beads through it to try and glue it from the top here. I'm just going to go right around. And I think this is medium CA glue that I got here. And I'm just going to go all the way around, kind of fill that gap. Don't know if this is true, but I was looking up online. I normally would use plastic cement, but I was reading that plastic cement isn't really good for PLA, so it said use CA glue instead, so that's why I went with that. So I'll blow a little bit on it and just try to maybe work it in there a little bit. Okay, so that's what that's going to look like. Now, you got your LED strip, which has the wires attached to it. I want to take these two that aren't attached to the connector, and I'm just going to cut them. I don't need them, and so I want them just not hanging out inside this thing anyway. Cut them a little bit at an angle maybe here. And then, there we go. So those are gone. So now I just got my 3-pin connector coming off of it here. Now these LEDs, this strip is longer than what it's going to take to go around this thing. So we're going to have to cut it. And to cut it, you just grab scissors, and I've not cut this yet, so the first time I'm doing it will be on camera. And you cut it right across any of those solder pads, and it shows you where a cut line is. Okay? And so what's important too on these LEDs is if you go to reuse the rest of your strip, one side of these LEDs, from what I understand, has a data in and the other one has a data out. So if you ever reattach a new set of wires to the remainder, you got to connect it to the right side for where your data is going to come in at. On the back too is also double-sided or sticky tape here. That's what we're going to use to hold this thing into the channel. So what I think I want to do here, I'm going to flip this up, and I'm going to go ahead and feed the wire through and kind of get it right on the edge there, okay? And we're just going to then go all the way around and stick this as close to the middle of the channel as we can get. All right, so I'm going to go ahead and unpeel this. Okay, and I want to get it so I can wrap the whole thing all the way around. So in fact, I might even take that first LED and I'm going to put it even a little bit into that hole. All right, I'm going to peel off a little bit. Wrap it around and stick it. Okay, and then on this side here, I'm going to try and get a nice straight line and keep wrapping it around. It's not as straight as I would like, so I'm going to try to fix that a little bit here. Press these into place. And let's get some more of the strip unwound here. Okay. I'm going to pull it tight, stick it down, and just press lightly on these. Be careful you're not pushing too hard on this lid. It is thin. I tried to make it light, so I only have it like 1.5 millimeters thickness. So if you put pressure on it, it will break and crack pretty easily. If you want to make yours stronger and bigger, thicker, go ahead. Just adjust grab the Autodesk Fusion file and adjust it as needed. Okay. So there's more of our LED coming around. We're almost home. Okay. So this is it wrapped all the way back again here. You can see under here is where we started. Now I'm going to need to cut these right at this solder pad part. So I'm hoping this works cleanly. If I just cut right here with some scissors. And let me go ahead and get rid of this garbage here. So I got a little bit of a strip left. I don't know, maybe 12 inches or so. So you can use that for something else, but you'll need to take your wire, I believe, and solder it to the remainder of those little pads there, if you can manage to do that. All right. I'm going to put this back away in my bag so I can put that away nicely later. Store that for future use. Got some garbage here. We're going to get rid of that. Now I should be able to just stick this right down there. Okay. Now we have these LEDs wrapped around nicely and stuck. So it looks like that going all the way around. Now your first LED, when you program these, you actually tell it how many LEDs are in the strip and how which LEDs to light up, and they're indexed by number. So your first one is this one that started here in the hole, right? And so that'd be 1, 2, 3, 4, 5, and so forth. We're gonna have to count the total LEDs so that we can tell the program that I'll show you in a little bit how big the whole strip is. It needs to know that so it knows where to end when sending the LED light commands. Okay, so that's there. This is glued. Now the other piece is this translucent material, this cover that I made that'll sit on top of the LEDs. So we're going to take that, okay, and it's kind of tight. It'll slide right over the cover here. And I only had like a green translucent material, so that's why I printed it in that. I'm not going to glue it today. I might change that out for a clear one. I don't know. I'm not sure I'm liking the green yet. So we're going to slide that over. And it covers the whole thing. So it should just wrap like that, okay? And then you got an LED strip in there with the translucent material all the way around, and this will be sitting on the top of your drone. Remember, the arrow on the lid, that points to the front, okay? And we started with our LEDs in the back, so number 1 is back here, all right? Now inside, we have our wire coming in, and we have our cable. So what I think I want to do is probably attach that to the side somewhere. And this wire is a little bit hard to bend because it's coming right off the LED strip. So how do I want to make this cable? That's what we got to figure out here. It's gonna plug in like that, and I'm gonna want to be able to easily remove the lid and just unplug these things. So what I think I'm gonna do for now, might change it later. I got these little 3M, I think they're 3M sticky pads that zip ties can attach to. So I'm going to go ahead and peel one of the backs off, and I should be able to, I'm going to take one. I might want to end up using two. Take one, and I'm going to run a zip tie through it and pull that cable tight to the side so it's not shaking in here. And you don't have to do this, but I've been doing this with a lot of my cables to add some extra protection. I'm going to try and put some split sleeving over it as well. Take that, cut it. The split sleeving basically just goes over the wires, right? It's got a little split in it, and you kind of unroll it, and it's a little bit tricky, but you can eventually get it to wrap these wires. See if I can do this here on the camera, or if maybe if it's taking too long, I might pause it and do it off camera. So kind of got to feed it in there and just work it with your fingers until it unravels and covers your wire. Yeah, I think I can get it. Here we go. Okay, so that covered the wire a little bit. Just a little extra protection for zip ties and stuff going over it. A little bit of vibration protection so it's not rubbing. Alright, so I got that tied down in here. Cut off the excess. And then this is going to be my cable that I can plug and unplug. So we got that ready to go. Now what I want to do with this guy as well, I'm going to put some split sleeving on this to hopefully hold it all together and kind of nice. Might even zip tie it a little bit. This is going to be the cable that goes inside the drone. Go a little bit bigger. Okay. I'll take that and try and lay the cable right in here. Get it started, and then this will cover up kind of these little joints that I made where I soldered the wires together and put some heat shrink tubing over it, and I got that resistor buried in one of these, so it'll hide some of my ugliness a little bit. Alright, so that's what that end of the cable looks like. And then I kind of purposely separated it into two here because one's going to go to power and the other one's going to go to the Raspberry Pi. If I was smart, I would have made these the same length, but I didn't, so something I'll have to live with. And I'm going to go ahead and zip tie these up towards the top here just to make sure the split sleeving isn't sliding all over. Put that on here. Cut that off. And see if I can trim up some of these little hairs from where I cut the split sleeving. Okay. And then lastly, I'll try and make those about the same size. This is 1/4 inch split sleeving here that I was just using. I also got some 1/8 inch that I'm going to go ahead and use for these other wires for right now. So I'm going to pull off a little bit of that and put that on the power wire. See if it fits. I don't know. It might be too small. So my red wire is a little longer than the black. I'm just going to try and fold it and lay it in there. And what I'm going to do there is I'm going to just try and zip tie it to hold it all together. You don't want to be cranking these zip ties down, because you'll just be cutting your wire, so don't go super tight with them. Okay. Now these two are going to go to the Raspberry Pi, and they're going to be somewhat close to each other, so I might do the same thing with the split sleeving, so that they're about an equal length. So we'll do that. And get these out of here. Alright, so let's try and do this last one here. Make these about equal length here. And I'm going to try and lay the sleeving, or the wires right in the sleeving now. Okay. Now you will need to know which one is which, so I'm going to pull out just a little bit of wire here so that I can see which one is green and which one is black, because it's going to matter which one goes to each port on the Raspberry Pi. And I'll put a couple zip ties here, again, to hopefully hold it all together. I'll put another one up here. Okay, so here's our cable, kind of all put together. And where I got kind of this bulge here where there's the connections between the wires and that resistor's in here, I'm going to put another zip tie right there just to help hold it all tightened together. Okay. Alright, so here's our cable. We got this connection that's going to go to the LED strip. And then we have this connection, one that's going to go to the data port on the Pi, to the ground, and then this is going to go to 5-volt power. Now the last thing I like to do is wherever I got power connections, I try to label them. So I got this label printer. This is totally optional, but I'm going to come here and I'm just going to put a 5 and a V and print this thing. And cut it off, and what it'll make is a nice little label like that. That says 5 volts on there, okay? And then you peel off the covering or the film on the back. Okay. And because I have 12 volt and 5 volt connections in the drone, I just like to have it labeled so I know which connections go where, so I don't accidentally power something with too much voltage. Alright, so there's a little label on this guy, and on the end you can see, I can now see it's 5 volts. Okay. And that's it. That's going to be your cabling and the lid for the drone. Next step is we're going to have to hook this up into the drone itself. So what I'm going to do right now is I'm just going to go ahead and plug this in. So I have this connection already made, and then I'll bring the drone over and show you how we're going to connect it to that. So here's what our cable's looking like right now. Connected in there. Kind of got a lot of extra, so maybe we'll want to do something with that yet. I'm not sure. All right. So I'm going to pause it there, bring the drone over, and we'll start to connect it to it. Be right back. Okay, now if you remember in the drone, this top board here is the compute board that I built in an earlier video. And there's a Raspberry Pi right here next to the HearLink unit. I'll try and move this over just a little bit. Now in the last video we had a couple cables running up. I have this extra CAN cable that's going to go to the RP, or not to the RP, to the LiDAR. And then I had this octopus cable that I built in an earlier video too, of a bunch of 5 volt out ports that I can use. Okay, so, and these come directly from the BEC. So what I'm going to do is in our cable that we made earlier in the video, I'm going to take the 5 volt connection and I'm going to attach it to one of the 5 volt out. I'm going to just kind of tuck this in here then to keep it all from bouncing around. Okay. And then the Raspberry Pi needs to have these two connections. So if you remember our green and our black wire, so black is ground on the Raspberry Pi, and that's going to go to the pin closest to the HearLink with the way I have this mounted, to pin number 3. Okay, and then the green wire is going to go to pin number 10. Or actually, I'm sorry, not pin number. The third pin in is where the black one goes to, and then the green wire goes to the 10th pin on the row closest to the heatsink here. The black wire goes on the row that's furthest away. So I'm going to try and count here. 4, 5, 6. So that's going to the 10th one in. Okay, and remember this black one goes to the third pin on the row furthest away from the from the CPU on the Raspberry Pi, the side closer to the ear link here. Okay, so third pin in from the back here, and then the green wire is 10th pin in. And that should leave you with the wire then hanging here that's going to go into the lid. Tuck those down a little bit. So we're going to grab the lid. I'm going to try and adjust the camera so I can capture all this. Okay. So now our lid, I've got the drone pointed forward here. Okay, so this is front up here. And if you remember, we got the little arrow pointing to the front of our drone. So on this lid, first I'm going to take this CAN cable and get that connected to the LiDAR. If you didn't do the LiDAR in the last video, you won't have this step. Okay, so we're going to connect that in to that L431 board. And then the other wire we got to connect is the one we just made to our LED strip. So I'm going to take that and plug it together. Okay. And then what you're left with is something like that, right, where all the cables are connected. I'm going to tuck those down. And this lid should just fit right on top. Make sure you got no wires poking out, getting pinched or anything. Okay, your LiDAR is pointing forward. And then what you end up with is there's the 4 screws around the lid here that line up with the holes in the top of the frame. And you're just going to screw your lid in. Oops. I think I'm just going to do 2 of these screws right now, just to speed the video along for you. Dropping my screwdriver today. All right, so those are all connected. Your Raspberry Pi is connected to your LED strip. Everything's powered. So you can go ahead and power up your drone now. So I'm going to plug this in. LiDAR is going to start scanning. No lights are going to turn on because we haven't run the program yet that will light them up. So let me go ahead and hop on over to the computer. I'll open up a terminal window to the Raspberry Pi. And I'll show you a Python script that can be used to light up these LEDs. Show you what we can do with it a little bit. Be right back. Okay, so the first thing we need to do is set up your Python environment so that you can install the appropriate libraries to control these LEDs. So in the video description, there's a link to my GitHub page, which should take you here to github.com/timarcher/drone. What I want you to do is go to the wiki and documentation home folder, and you're going to see a list of all the videos on this page here. Now, this video, we're on video 18 here, the scanning lights, but it assumes you've already done the onboard computer and Ethernet. In this video is where we installed Ubuntu 24.04 on the Raspberry Pi and got it all set up and connected into the drone. So you need to have a running Pi for this part of the video to work. If you haven't, go ahead and click in onboard computer and Ethernet, and there's a link to the video here. You can watch and go through all of the appropriate steps. For this video, though, I'm going to click on video 18, the scanning lights. I'm going to go into there, and here's a lot of the information that we set up here and did previously. But what I want to do is open up a terminal to my Raspberry Pi now. You might want, I use MOBA Xterm. I pay for this. You might want to use a free one such as PuTTY to SSH in, or you might have a monitor connected to your Pi. It really doesn't matter. So I'm going to go to my drone here. I forgot to actually turn the drone on, so I just had to go do that. So let's wait a second for this thing to boot up, and then we should be able to connect into it. But ultimately, what we're going to want to do is we're going to install Python pip. We're going to make a Python environment, and in that environment, we're going to install Pi 5 Neo. So let's go and see if we're booted up yet. I'm going to retry to connect. It'll take a minute for this thing to fire up. There we go. So I'm now connected to my Pi here. And let's just split the screen again so you can see it all. And what I want to do is we're going to start here in the wiki page, sudo apt update. So I'm going to paste that in here in my terminal and run that command. It may ask you for a password that you set up when installing a Raspberry Pi. If it does, go ahead and just type that in. The next command we're going to run is this sudo apt install python 3-pip. That will ensure you have pip installed. I've already installed it, so there was really nothing to do. Yours might take half a minute or so to get it installed. If it asks you, to confirm yes, you want to install it, go ahead and hit that. And now what we're going to do is install a Python virtual environment. What this does is creates an environment where when you install other pip libraries, it will keep them in that virtual environment so they don't collide with other virtual environments that do other that run other programs for you. So that created that. I created a virtual environment called scanning LEDs. I ran this command python 3-m venv for virtual environment scanning LEDs. And now we want to activate it. So let me clear the screen over here. There we go. Kind of restarted this. We're going to run that source scanning LEDs bin activate. And now you can see in my command prompt, it added this to the prefix here telling me that that environment is now the active one. And lastly, we're going to do pip3 install Pi 5 Neo. So we're going to run that. And that's going to install that library right in our virtual environment. So now what I have here next is a simple program that lights up the LEDs. And so what I'm telling you to do here is make a file called ledtest.py. So I'm going to make one led_test.py. And use your favorite editor. I use VI. You might use Nano. Doesn't really matter. So I'm going to grab this code here and I'm going to paste it in. Now in this code, we're importing our Pi 5 Neo library on this first line here. And you're going to need to count how many LEDs you have in your strip. Mine ended up with 97 LEDs from where the start was to where I cut it. You might have 98, might have 96. We should be close, but you might be off a little bit. So make sure you tell it how many LEDs you have. This next line of code here, we're going to initialize the Pi 5 Neo library. And we're going to tell it that there's 97 LEDs, and I want to talk at 800 kilohertz to the LED strip. And then lastly, here's a couple really simple commands that you can see. This LED or this fill strip is going to say take the whole strip, all 97 LEDs, and you're going to tell it what RGB colors to use. So this first 255 stands for 255 brightness of red. The next one where it's 0 is green. And the third one is how much brightness of blue you want. So you can get different color combinations by mixing your red, greens, and blues. The 255 part goes from 0, which is off for that color, to 255, which is full intensity of the red channel on that LED. And then you run this script or this command here, neo.update script or update strip, which will tell it to take all those LEDs that we just filled and make them red. Next, I got one more command here just to show you how you can set one specific LED color. So this one I'm saying take the fourth LED and I want to set it to blue. So these next three numbers here are red, green, and blue. So red, I don't want any, I want it to be 0, no red light or intensity, no green intensity, and I want full blue intensity from 0 to 255. And then we're going to say update strip again, which will set that LED color. If you give me a second here, I want to attach the camera so I can film this strip starting up. Okay, so I just hooked up my camera to the, pointed at the back of the drone. And I'm going to go ahead and save this program here. So in VI, you right quit. And what I want to do is run it. So to run it, you do this next command, python3 led_test.py. You execute it. So if I go ahead and run this, you should see all of your LEDs in your strip light up in red, and the fifth LED should be blue. Because if you remember, we did this set LED color and we said 4. So these LEDs start at, they're 0 index. So 0 in this set LED color is really your first LED. 1 is your second LED. 2 is the third. 4 is the fifth. Okay, so I'll try and put that in the overlay this video when I edit it so you can see what the lights look like all turned on. So let me pause here and we will then show a couple other ways of playing with these LEDs. Be right back. Okay, I switched the drone around so that the camera is now looking at the front of it. And what I want to do is walk you through a couple other programs that I got on this wiki page. So down below, the code we were just walking through, and by the way, this deactivate and remove the virtual environment, you don't have to do. That will actually delete it, so you'd have to recreate it next time. You can just leave it alone and leave it there for the next time you want to log into your Pi. You will have to run activate again. The source scanning LED has been activated to activate that virtual environment if you log out and log back in, but you don't have to actually delete it. So let's take a look at these 3 scripts I got here. This first one will just start at one end of the one end and light up one LED at a time, making like a loading bar type of effect. It's mainly used to use the functions to interface with the light strip to demo how they work. So I'm going to right click and open that in a new tab. And I'm just going to go ahead and copy this code. And if we call that led1.python and I paste it in, you can see in here, I'm telling it I got 97 LEDs again. And here's some code here that will just go every, 0.2 seconds. So every 200 milliseconds, it'll light up the next LED. So if we run this program, and we're going to do python3 led1.python, we're going to run that. It's going to take a minute to get around to the front because it actually starts at LED 0, which is in the back. But you should start seeing them light up. So there they go as they go around the drone, lighting up each LED at a time. Okay, so that's kind of a fun one. you might use a program like this to monitor your battery percentage, for example, and set the LEDs, the number of them lit up equaling the percentage of battery life remaining. So here's a second one here. So there's a scanning LED pattern where the strip gets lit up in red, and then 7 LEDs will scan back and forth, starting from the first LED, going all the way to the end and back again. I got it set to light up in blue. However, it'll show up in green on this because remember I got that green translucent kind of cover on this. I actually, that's why I want to get a clear one and some clear PLA and reprint it. So if I copy this program and I do led2.py, and we're going to paste that code in, I'll let you read all this. There's a bunch in this code, right? But this top section here is the user configurable variables where you tell it you got 97 or 96 or however many you got, and how fast you want it to move, and what color you want your strip to be in. So this will light the whole thing up in a red color at, I don't know, about a 20% intensity, because it goes from 0 to 255, this number, and I set it to 50. And then I want 7 LEDs to scan, and I want their gradient color to be, you know, or the intensities. I want the middle one, this 255, to be the brightest, right? And then they get slightly duller as they branch out to the 3 LEDs on either side of the center one. And then the scanning color, 0 red, 0 green, 255 blue, so brightest intensity of blue. And the rest of it is just boilerplate code for the functions that run it. So if I do this, led2.py, you see the whole thing lit up in red, and you can see the little green kind of scanning bar go by. And in a second here, it should come back around. And it just keeps going from one end to the other and back. So it's a fun little pattern to play with. And this one will go forever. You got to hit Control-C to stop it. Right? So that actually killed the program. And will let us move on to the next one. The third one is more like the Cylon pattern where it starts from either end and meets in the middle. So I'm going to grab that code here. And it's very similar to what the one we just did. We paste it in. If you go to the top, it's very similar in that it's got the gradient and the color, right? I got a low intensity red and then a blue. And this one I'm only scanning 3 LEDs because there's 3 that'll come from each side and they will meet in the middle at the front of the drone. And then they'll bounce back. So let's run this one and I'll show you what that looks like. led3.py. And you should see a couple LEDs come from each end. They'll meet in the middle of the drone and then they'll bounce back. So this is kind of a fun pattern to play with too. You might want to make this one active on your drone. I think this is the one I'm going to go with. I'll have to figure out how to put this into a startup script or trigger it maybe through an RC channel. That's more to come in a later video where we start interfacing with the Pi and the flight controller at the same time, right? So maybe I want to turn on my navigation lights, and doing so will initialize this program to turn on the scanning LEDs as well. So that's it for this video. Shows you how to set up those LEDs and play with these NeoPixel lights. Kind of cool stuff. Fun things to add to your drone. Not completely functional, right? You might find a use for it, like I said, displaying the battery percentage, or maybe giving you some other visual feedback to the state of the drone. But here's the basics of how to use it, and I hope this helps you do some fun things with your drone. Until next time, have a good one.